Okay, yesterday we started talking about graphs of the reciprocal trig functions and secant, cosecant, tangent, cotangents. When I'm dealing with the secant and the tangent, our guide's going to be the cosines. If we have a co there, cosecant and cotangent, our guide will be the sine. Okay, so that's something that you can maybe put in your mind. When I have a cosecant or cotangent, my guide's going to be my sine. Tangent and secant, the guides will be the cosine. When they're talking about where the guide function crosses the prime axis, you're going to get vertical asymptotes. You get vertical asymptotes. When you're talking about secant and cosecant, your graphs will be asymptotic parabolas. When you're talking about tangent and cotangent, tangent, we have upper right to lower left. It's a cube function. When we look at the cotangent, we have upper left to lower right. These are all the cues that we talked about yesterday. Sort of put a little synopsis here that we will continue to follow. The cues that I will give you will be the same ideas that we have right here. Let's take a look at problem number 18. Problem 18. Bless you. Let's take a look at 21 instead. 21. We'll take a look at 1 theta 1. We'll take a look at 1 radian 1 also. Bless you. Problem 21. We have y is equal to -1 plus 3 cotangent of 2 theta minus 30. Okay, the first thing you're going to want to do, okay, you're going to want to write in there what's going to be our guide function. Is it going to be a sine or is it going to be the cosine? If I have a cotangent, will it be sine or cosine? Sine. Now, if you want to rewrite it, that is fine. Or you can just write sine up above it. So you know that's what I'm going to be dealing with. Now, if we take a look, our variable is theta, which means we are dealing with degrees. That's important when you go to calculate the period, because the period is 360 divided by our b value This is our theta. Hope my voice holds out. So like we did with our trig functions that we are graphing sine and cosine last week, what's your amplitude, what's period, what's vertical phase shift, what's the horizontal phase shift? Okay, this is not, there's nothing changed to what we had to begin with. Okay, what we did last week. We took our equation, we found the amplitude, we found the period, we found the vertical, we found the horizontal phase shift. Grant, what do you have for the amplitude period? 3 and 180. Our B value is a value of 2. So we have 360 divided by 2, so we have 180. Vertical horizontal phase shift. Chloe, what's a vertical horizontal phase shift? And horizontal? 30. Okay, what's our vertical phase shift? What's being subtracted? So we go to our graph now. Let's see here. We have vertical phase shift to -1, amplitude of 3. We don't really have to shift too much off of our axes. The period's 180, so I'm going to make my 90s a little bit bigger. And then divvy it into thirds. First thing we draw in, what do we look at? What's our first thing we look at? Sydney? No, before that. First thing we draw in. Vertical phase shift. Draw on your prime axis. So at -1, draw on your prime axis. Once again, these Q's are going to be the same thing we did last week. Second thing we look at, horizontal phase shift in our trig function. Horizontal phase shift tells us your theta start value. Your trig function will tell you, do you start on the prime axis or at peaks and valleys? So we're going to start at 30. Prime axis or peaks and valleys, Johanna? Prime axis. So 30, we're on the prime axis. Oopsie. 30, we're on the prime axis. Third thing, we take a look at the period. That will tell us a degree measure. We'll be back at the exact same spot. So if we're at 30 on the prime axis, What's our degree measure for where we'll be on the prime axis again? Get a point down there. Abby? 210. Then we start playing our games of halves. Halfway between 30 and 210. We should be on the prime axis again. And divide by 2 is 240, 120. Halfway between 30 and 120. We'll be at a peak. Halfway between 120 and 210, we'll be at a valley. We have to take a look at our amplitude. Our amplitude will tell us what we go up to. That's from the prime axis. Should be at 75. $165. 75, what's our, where do we peak out at, Brendan? 2. Have to go 3 up from the prime axis, we're at 2. Okay, 120, 210, we have to go to a valley value. What's our valley value going to be? Laura? -4. So here's our sine curve. Okay, now we go into how we graph the secant and cosecant function, or the cotangent or tangent. Wherever we hit the prime axis, we draw in our vertical asymptotes. Okay, so wherever you hit your prime axis, you draw in your vertical asymptotes. And then we look at a cotangent function. Cotangent function goes from upper right or upper left to lower right. It is a cube function. Okay, our square functions, our parabolas are like this. Our cube function, we just drop one of our arms. Okay, so I'm curved here and curved down. The halfway point, we cross our prime axis. We don't cross here. Okay, we don't cross down here. The halfway point, we cross the prime axis, and we have a cube function. And they'll be asymptotic. Let's look at problem 23. I know you didn't have to do it, but we're going to do it because I want to do a radian problem in there. So this should be for everybody. Y equals 4 plus 6 secant pi over 2 x plus 1. First off, we throw in our guide function. We have a secant there. So Nolan, what are we going to use as a guide function? Cosine. We're going to use our cosine. So we have an amplitude, period, vertical phase shift, and horizontal phase shift. Now, we are in x, and we are in radians. So this changes how we calculate the period. Period was 360 divided by b. but now we have 2 pi divided by our b value because we had to change into a radian mode. And what I suggested to do yesterday is write it like that, 2 pi divided by b. Now, when dealing with radians, as you do more of these and you're dealing with radians, you're just multiplying your denominator by 2 is what's occurring each and every time. Because you're going to flip your fraction. You're going to flip your fraction. The pi's are going to cancel out. It's going to be 2 times whatever your denominator is. So go ahead and calculate the amplitude, period, vertical, horizontal phase shift. Amplitude, period. Brandon, what do you have?
Amplitude 6 and
Well, we have 2 pi divided by pi over 2. We flip the pi over 2. Flip the pi over 2. So we have 2 pi times 2 over pi. The pi's cancel out.
So
4. Value 4. The pi's will go bye-bye. So we have 2 times 2, which is 4. Vertical, horizontal phase shift, Joey, what do we have? 4 and negative 1. We have x minus a negative 1, so we have 4 and negative 1. So we look at the graph of this. And we're going to be a little bit top heavy because we have amplitude of 6 and a vertical phase shift of 4. So I'm going to be top heavy on this. The nice thing about dealing with radians is your numbers get really small. Because now we're just dealing with an X number line. Vertical phase shift, once again, first thing we draw in our prime axis. So the value 4, we draw on our prime axis. Second thing we take a look at, our x start value and our trig function. We start our x at a value of negative 1. Cosine tells us to start at peaks and valleys. So you have to take a look at your amplitude to get your peak. So I'm at 4, I'm at -1 for my x. My prime axis is at 4. I have an amplitude of 6, so that's going to take us up to what, Rachel? 10. So it's going to take us up to 10 at -1. We have a period of 4. I'm starting at -1. I go 4 out from -1. I'll be at the exact same spot. So if I'm taking -1, add 4 to that, we're out at 3. And we'll be at our peak again. Between two peaks will be a valley. Halfway between -1 and 3. And like I said, the nice thing about this, our numbers get really small. -1 plus 3 is 2. Plus, divided by 2, I have 1. We'll be at a valley value. So if I'm at 4 and I have to go down 6, we'll be where, Paige? -2. Halfway between -1 and 1, and 1 and 3, I'm on my prime axis. Once again, a lot easier to deal with here. So at 0, I'm on the prime axis, and at 2, I'm on the prime axis. Wherever we wherever we cross the prime axis, we have our vertical asymptotes. So at 0 and at 2. Now we're talking about secant cosecants. We have our asymptotic parabolas. So from any valley and any peak, we are asymptotic with our parabolas. Now once again, you could do this one of two ways. I do my full one down here. I could do 2 half ones here and here. Or if I wanted to find my next asymptote, I have one at 0. I have one at 2. My next one will be where, Odessa? If I'm at 0 and 2, my next one will be at 4. So I could draw in another asymptote out here at 4. Or I could go back to -2, whichever one you want to do. Or you could do 2 half parabolas. It's up to you. Either one is acceptable. Questions on graphing? Once again, as I talked about, going back to what we did with our previous graphs, makes it a little bit easier. Okay, we have an in-class assignment today. We also have a worksheet today. Quiz will get moved to Thursday or Friday, depends. If you're a sophomore, it will be on Friday. If you're a junior or a senior, it will be on Thursday. When you're done with this, you can hand this in. You have a worksheet that is sort of like a review for the review sheet. Woo! And my voice will hold out. Thank goodness I had COVID 3 weeks ago, and then I don't have to worry. You guys don't have to worry about this. It's really weird. It's just my voice just went away. No other symptoms of anything. Just I have no voice. No. It's really weird. Once again, when you're done, you can bring it up and hand it in. And there's a worksheet up here. I thought there was a worksheet up there.